Good morning, guys. My name is Radhey Bairagi. Hi, all. At 5:30 a.m. In the morning, let us play with civil engineering problems together. Okay, so I'm here to discuss some most important civil engineering questions here. So let us memorize those questions within 5 to 10 minutes. Okay, let's come together. Okay, this is the civil engineering book, which is very interesting and very good book. As you all know that civil engineering JN exam is cancelled out. So next recruitment is coming soon. Okay, and we need to be continue to our studies. And as I am studying continuously, and I am fourth time reading this book. This is my fourth revision. I'm reading this book from approximately September. Okay, before that I have read three different books: Engineers Academy and IS Academy. Okay, so I have made some 4,000 notes also. Okay, so after all studying things, I'm doing some important points. Okay, I'm bringing some important points for you after studying all these things. Okay, so let us play some important examples. So yesterday I was solving determinacy, indeterminacy, and stability of structure. Structure is the very important part, very important part of civil engineering concepts. So this is the structure. Here you can see the structural analysis. Have you read structural analysis? See, 24, 28, on 28, this was my third revision, sorry. Okay, so this is running third, not fourth. So see, determinacy, indeterminacy, and stability of structure. Force method of analysis, displacement method of analysis, where stop deflection method, and displacement method of analysis, moment distribution method. Then trusses, influence line diagrams, and matrix method of analysis. Generally in RSMSSB JN exam, trusses, influence line diagrams, and matrix method of analysis are not coming, not important at that much. Okay, so see, let us play with question number 19. A two-hinged arch is statically indeterminate by what? By 1 degree. See, two-hinged arch statically indeterminate. You should remember it. Just remember it. Don't think and don't find a concept. Just remember, two-hinged arch statically indeterminate by 1 degree, and an arch with three-hinged structure is statically determinate. Two-hinged arch is statically indeterminate by 1 degree, and an arch with three hinges structure is statically determinate. Okay, so you remember both these things. Question number 21. In a three hinged arch, the shear force is usually maximum at springings. At the springings, the shear force will be maximum in three hinged arch. Okay, now the next question. If the beam is supported so that there are only three unknown reactive elements at the support, these can be determined by using the following fundamental equation of statics. Yeah, this is, no, we know all horizontal forces, summation of all horizontal forces will be 0, vertical forces will be 0, summation of all the moments will be 0. So these three equations will help to find the unknowns. Okay, and see, which one, question number 23. Which one of the following is not related to the types of arches? See, two centered arch is related, semicircular arch is related, three centered arch is related, rendered arch is not related. See, the incorrect answer is rendered arch. Okay, first three are related with the arches. Question number 24. The lateral deflection of a frame is called sway. Very important questions. Generally, examiner asks sway. The lateral deflection of the flame is called sway. The next one is question number 25. Which one of the following is correct? Okay, there are four options. We need to find the correct things. First one is, a statically indeterminate structure is the one which cannot be analyzed at all. No, can be analyzed. Okay, so first one is wrong. Second, a statically indeterminate structure is the one which can be analyzed using equation of statics only. Statically indeterminate can't be analyzed by using static equations. We need to like we need to some extra things required here, that is deflections and that is slopes, okay, compatibility equations. So only static equation we cannot analyze this. Okay, so this is also incorrect. See, a statically indeterminate structure is the one which can be analyzed using equation of statics and compatibility. This C is the correct. We required static and compatibility equation to solve statically indeterminate structures, right? So C is the correct answer. Let us see 4 also. A statically indeterminate structure is the one which can be analyzed using equation of compatibility only. No, we need static also. So C is the correct answer in question number 25. Question number 26. Which one of the following is correct? Here they also given 4 options. We need to correct one. So is a determinant structure cannot be analyzed without the correct knowledge of modulus of elasticity. No, can be analyzed. Okay, so C is the correct. There is a role of modulus elasticity, but we cannot say that without correct knowledge of modulus elasticity we cannot determine structure. Okay, we cannot analyze it. Okay, so C is the wrong answer. B, a determinant structure must necessarily have roller support at one end. Is no, it is not necessary condition. C, a determinant structure requires only statically equilibrium equations for its analysis. This is good. This is right. A determinant structure requires only statically equilibrium equation for analysis. So C is the correct answer. D is also wrong. A determinant structure will have zero deflection at its end. No, it is not necessary. Okay, so D is so wrong. Let us play with the question number 27. The graphical condition of equilibrium of concurrent forces is that a force polygon should be closed figure. Force polygon need not be closed figure. Funicular polygon should be a closed figure. Both the funicular polygons and forces polygon should be closed figure. Yes, here see, funicular polygon should be closed figure, force polygon should be closed, should not be closed figure. So these A, B, C are incorrect here. See, the option 4 is correct. Both the funicular polygons and force polygons should be closed figure in the graphical condition of equilibrium. Okay, concurrent forces. Done. So question number 28. Which of the following is indeterminate? What? Simply supported indeterminate? No. A propped cantilever internal hinges? No. Cantilever beam? No. Beam with both ends fixed is called indeterminate. It was came in PhD Rajasthan. Okay. No matter it came in PhD Rajasthan, it is very important question. See, simply supported beam, a propped cantilever with internal hinges, cantilever and beam with both ends fixed. The beam with both ends fixed are indeterminate and can be analyzed by using static and compatibility equations. Okay, so let us play with the question number 29. See the question number 29. For a pin joint plane frame, the relation between number of joints J and number of members M is given by. See, the relation he is asking, M is equal to 2J minus 3, M plus R minus 3. Okay, so R is 3, so M is equal to 2J minus 3. Okay, so the things which I have written using pen is not here, please don't see that. Just see the question. For a pin joint plane frame, the relation between joints and member will be M is equal to 2J minus 3. Just memorize this, because in the examination you can't you should not have time to solve these. So just remember, M is equal to 2J minus 3. That's it for pin joint plane frame. That's it, nothing else. For pin joint plane frame, M is equal to 2J minus 3. Let us come to the question number 30. The frame is, figure has given. See, this is the figure. So you will see here. Okay, what they is asking? They are asking one unknown reaction components 2 unknown reaction components, 3 unknown reaction components, 6 unknown. See, this is the fixed end, and at the fixed end, how many reactions happens? 3. One moment, 2, one horizontal, one vertical. So 3 plus 6 unknown reactions. Sorry, reactions are here. So how many unknown reactions are here? 6 unknown reaction components are here. 3 as one fixed support, 3 at another fixed support. Okay. So let us come to the question number 31. A rigid portal frame ABCD carries load W1 and W2 as shown in the figure. Okay, W1 and W2. So the structure is statically determinant है कि indeterminate है. Let us play with this. See, M plus R minus 2J. So members are how many members are there? 1, 2 and 3 members are there. Okay. On reactions, how many reactions? 2 at one end, 2 at other end. 2 to 4 reactions are there. Minus 2 into J. J is the joints. 1, 2, 3 and 4 joints are there. So 7 minus 8 means 1 degree indeterminate to be first degree. This is the structure. See, they can change the values, but structure will remains like this. This is the indeterminate structure of first degree. See, okay, and remember. Question number 32. The number of unknown reactions to be found at a fixed support of a beam during analysis is how many? 3. Okay, at a fixed support is 3. Let us play with question number 33. The static indeterminacy of a square truss with 2 diagonal members are hinged support. See, a statical indeterminate of a square truss. This is the square truss with 2 diagonal members are there. See, I have written with the pen. This is the diagonal member. Okay, this is the diagonal member, and this is the what? This is what? This is called square truss. Okay, the all 4 sides are the same. So what he is asking? Static indeterminacy he is asking. So what is static indeterminacy? Static indeterminacy is given M plus R minus how much? Minus 2J. This is 2J. Okay. So when you will solve these things, M plus R minus 2J for this, because this is square truss is given. Okay. So see, M member is how many? How many members are there? 1, 2, 3 and 4. 5 and 6. 6 members are there. Okay. So M is 6. Reactions is what? Pin joint. Hinge supports at the hinge support. Okay. So at the hinge, how many reactions will be there? At hinge? See the reactions. Let us see the solution of this problem. Question number 33. 33 is here. Or this is the 33. See. This is the question number 33. See the question number 33. See, M plus R. So M members are 6. Reactions are 4. 2 at one end, 2 at other end. And minus 2. Joints are how many? 1, 2, 3 and 4 joints are there. Okay, this is not the joints. Okay, only these joints. So 6 plus 4 minus 2 into 4, 8. 8 minus 6 is what? 6 minus 8 is minus 2. Minus 2, 4 minus 2 is 4, 2. So degree of static indeterminacy is 2. So degree of internal indeterminacy is what? Degree of static indeterminacy minus external indeterminacy. So external will be how much? R minus 3 for this particular structure. This is the formula for this particular. They can ask the external indeterminacy also. Okay. So 4, R is 4, 3 is DS. Sorry. DS is how many? Sorry, R is 4 and minus 3. So DE will be 1. So when subtract DE from DS, it will come to 1. So this is called 1 degree of internal indeterminacy. Question number 33. The correct answer is internally indeterminate to 1. Internally, externally indeterminate to 1. Externally also 1. And degree of static indeterminacy is 2. Okay, all these 3 questions are here. Examiner can ask any of 3. Okay, 3 questions we have studied in just 1 question. Let us move to the next. The kinematic indeterminacy of two-story, two-bay plan frame with fixed base is what? Two-story, two-bay plan frame. See, 1, 2 and 3 supports will be here, and plane frame is here, fixed base is here. So at the fixed base, there are 3 reactions at each point, will be 9 total reaction, and decay is the kinematic indeterminacy will be 3j minus r. 3 is what? 3 will be the number into j will be joints. How many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 joint will be 9 by 3. 9 into 3 will be 27 minus reactions will be 9. So 27 minus 18. 18 will be the answer here. Got it? Reactions will be 9. 3 at one fixed support, 3 at other, and 3 at third one. Okay, so total 9. Let us move to the question number 35. Please don't look this was my practice at the first time. Okay, so maximum number of unknown forces that can be determined in concurrent forces system under equilibrium is how many? See, how many? The maximum number of unknown forces can be determined in concurrent forces system under equilibrium is only 2. Okay, so this is very good. This came in previous questions also. You just remember the concept. Fixed beam is indeterminate to which degree? Third degree. Remember this. Just memorize this. Fixed beam is indeterminate to which degree? Third degree. A propped cantilever is indeterminate externally. See, external indeterminacy he is asking r minus 3. Okay, degree of static indeterminacy is the summation of internal and external indeterminacy. So externally is asking, so r minus 3. So r will be reactions at the fixed support is 3, and here will be 2. So 3 plus 2 5. 5 minus 3 is 2 degrees, second degree of indeterminacy. Let us come to the question of 38. A cantilever beam is provided with a vertical prop. It is free. See, prop is here, vertical. At the free end, the prop is here, and the fixed end. Okay, this is a cantilever beam, or you know the meaning of cantilever beam. One end is fixed and other end free. See, a vertical prop at its free end, its static indeterminacy will be increased by 1. How? M plus R minus 3J. Okay, so M is 1 plus reactions is 3. Okay, minus 3J. 3 into joints will be 3J. So 4 minus 9 is 5. Okay, now see, 6 minus 3 into 2. No, this is incorrect. You just see, just remember that there is one cantilever beam. Okay, and cantilever beam is having degree of indeterminacy, static indeterminacy. You can calculate, easily calculate. You can. Okay, and then if you are applying a prop at free end, then its degree of static indeterminacy will increase by 1. Increased by 1. That's it. You should remember this only, not anything else. Okay. So this is question number 38. Let us move to the question number 39. See, very good answer. In plastic design of structures, if degree of statical indeterminacy is J, the number of hinges P required to convert the structure into mechanism is called. See, remember this. P is equal to joints plus 1. In plastic design of structures, if degree of static indeterminacy is how many? How much? J, the number of hinges P required to convert the structure into mechanism. What? P is equal to J plus 1. Just remember this. They can give the value of P. They can ask the value of P by giving J. Okay, so please remember P is equal to J plus 1. Question number 40. The degree of static indeterminacy NS and static degree of kinematic indeterminacy nk for the plane frame as shown in the figure. Axial deformation is neglected. So if they are asking axial deformation is neglected means what we will do, we will subtract the members from the degree of freedom. So how much degree of freedom here? Okay, see, please remember at this corners the degree of freedom will be 333. So total 9 degree of freedom. Okay, and at the fixed support there will be 0 degree of freedom. At the hinge support there will be 1, and here also 1. So degree of freedom is what? 333, 9, 10 and 11. So if we will subtract 11 from member 1, 2, 3, 4 and 5, how many members are there? 3, 5 members are there. From if we will subtract 5 from 11, there will be how much? There will be 6. So B is the correct answer. Kinematic indeterminacy will be the 6. C, 6. Okay, and what is static indeterminacy here? You can calculate static by 3m plus r minus 3j. Okay, 3m plus r minus 3j. So here will be how much members? How many members are 3m plus minus 3j? So 15. See, members are 5. So 15 plus reactions are how many? 3 will be here. 1, 3, 4, 5. Okay. So reactions, how many reactions are? 5, 6, 7.